These guided notes are on Scatterplots and Correlation for Chapter 3.1. Take a second to read through pages 143 through 144 on explanatory and response variables. Why do we study relationships between two variables? We basically do it to make predictions, explain phenomena, but we're also now using two quantitative variables as opposed to one, as we were doing in the previous chapter. What is the difference between an explanatory variable and a response variable? A response variable measures the outcome of a study, while an explanatory variable may help explain or predict changes in a response variable. So an example would be different drugs used to treat illnesses. The explanatory would be the different drug, and the response would be the time to recover. The time to recover depends on that different drug. Let's look at a check your understanding. 1. How does drinking beer affect the level of alcohol in our blood? The legal limit for driving in all states is 0.08. In a study, adult volunteers drank different numbers of cans of beer. 30 minutes later, a police officer measured their blood alcohol levels. So we want to look and see what is our two different variables. We have different numbers of cans of beer and blood alcohol levels. So our explanatory is the number of beers, and our response is our blood alcohol levels, because the blood alcohol level depends on the explanatory, or the number of beers. The National Student Loan Survey provides data on the amount of debt for recent college graduates, their current income, and how stressed they feel about college debt. A sociologist looks at the data with the goal of using the amount of debt and income to explain the stress caused by college debt. So we have amount of debt and we have stress. So what causes what? Our explanatory is our college debt. And what the college debt is doing is it is causing the stress. Take a second and read through Displaying Relationships, Scatterplots, pages 145 through 146. How do you know which variable to put on which axis of a scatterplot? Where do you start each axis? So your explanatory will be your x, and your response will be your y. Your x and y axes do not have to use the same scale, and it does not have to start at 0, 0. What is the easiest way to lose points when making a scatterplot? Hopefully, by reading this comic, you guys can figure it out. A common error is that students lose credit because they forget to label the graphs. Including the proper labels is more important than graphing each point precisely in the right place. Describing scatterplots. So what 4 characteristics should you consider when describing a scatterplot? First, we want to think about our direction. Is it positive, is it negative, or is it none? Not an absolute relationship. So 2 points that don't follow an overall trend. And then there's unusual features. Outliers, who are outside the overall pattern, and clusters. Form would be linear, nonlinear. And lastly, strength, how closely the points follow the form. A common error is if students are asked to describe a scatterplot, they are expected to discuss the direction, form, strength, and association, and possible outliers. Just like SOX, we use DUFS as an acronym to remember. Think Homer Simpson. The following scatterplot shows the amount of sodium in milligrams and amount of fat in grams in salads from McDonald's with no dressing. Describe the relationship between sodium and fat. Here is a scatterplot. So there is a positive association between sodium and fat. Salads with more sodium tend to have more fat. There are 3 distinct clusters, possibly no chicken, grilled, and fried. Not friends, sorry, typo. And each cluster has a positive linear association. However, the overall association is nonlinear. Since the points do not deviate from the cluster's nonlinear form, the association is fairly strong. Also, there are no apparent outliers. Take a second to read pages 150 to 151. Just like two distributions can have the same shape and center with different spreads, two associations can have the same direction and form, but very different strengths. Take a look to the right. Both of these are positive and are linear, but one is weak and one is strong. So what is the correlation R? What R does is it measures the direction and strength of the relationship between two quantitative variables. What are some characteristics of the correlation? Well, we know that R is between -1 and 1. R is less than 0 means a negative association, while R greater than 0 is a positive association. R close to 0 means weak, and R close to plus or minus 1 means strong. Here are some examples. Correlation. Which association is more linear? One with 0.5 or one with 0.9? You can't determine the form of relationship using only the correlation. Does a correlation of 0 mean an association is weak? Here are two examples. Just because a correlation is 0 doesn't necessarily mean it's weak. It could also be linear or nonlinear. Is correlation a resistant measure of strength? Well, an outlier in the pattern makes R closer to 1 or -1, while an outlier out of the pattern makes R close to 0. Calculating correlation. Read pages 152 to 157. How do you calculate a correlation? Here's your formula. Don't worry, we're going to be able to do this on our calculators. Here are the data on the lengths in centimeters of the femur, a leg bone, and the humerus, a bone in the upper arm, for the 5 specimens of an Archaeopteryx, I think that's a dinosaur, that preserve both bones. So we have our femur and our humerus. So your task is to make a scatter plot, describe what you see, and then find the correlation for these data. Does it agree with your description in part A? So take a second to pause the video if you want to do it on your own. Here is my scatter plot. So the scatter plot represents a fairly strong positive linear relationship. When I find the correlation, I get R is 0.994, which confirms my description. A fun fact about chocolate eaters winning the Nobel Prize is that according to this graph, it means that, I guess, the more chocolate consumption per year there is a correlation with how many Nobel Prizes places have won. To help you guys with finding the correlation, I have also included a video link in the description, which will show you how to do it on your calculator.